Okay, so for this first problem, the first thing you would do is you would factor it as much as you can. You want to simplify it. So in this case, you can factor this out, 5x minus 2, and you could factor this. If you're not sure, just through your head, then normally you would factor this with the x method. You would put a times c on the top, so it would be 2 times negative 15, and that would be negative 28. And then on the bottom, you would put 3x, or 3, on the bottom. So you would try to come up with two factors that multiply to equal the top, but when added together equals the bottom. So hopefully you got positive 7 and negative 4. But because this value, this 2x, is greater than 1, then you would have to move on to the box method, which is right here. Then what you would do is you would put the 2x squared right here. You could put the negative 14 right there. You could put the 7x right there. You could put the negative 4 right there. Sorry, negative 4x. So you want to think about two things when multiplied equals 2x squared. You know, it'd be, one of them would be 2x. Does it make sense to put 2x on top? If I put 2x on top, you can see that it would be 2x times something equals 7x. That doesn't make a lot of sense. And then if I put 2x here, I could possibly get 2x times x equals negative 4x. Well, if that was negative 2, negative 2 times something equals negative 14. Well, that's probably 7, positive 7, and then there are my factors. So this reduces to 2x minus 7, or it factors out to 2x minus 7 times x minus 2. So what I just did there is I factored it out. There is also factoring by grouping if you wanted to do that, but I guess I can save that for another time. So what we would do is we would try to eliminate any things on the tops and bottoms, just like we've been doing in the last couple of days. It'd be 5 over 2x minus 7. Okay, so our first step here is to simplify. So I would say this is our first thing we're going to simplify. The second thing we can do here is now that we know how to simplify it, we can find the horizontal asymptote. The horizontal asymptote. So horizontal asymptote, in this case, we have three rules which are written down right here. If you can't see it, but I am going to rewrite it. So the first rule, and if we look at our graph, is a times x to the m and b times x to the n. The only ones you have to worry about are the ones with the greatest exponents on the top and on the bottom. So the only ones you have to worry about are the greatest exponents on the top and on the bottom. Okay, so our first scenario is if the variable on top is less than the one on the bottom. So an example of this might be where you have x to the second power and you have x to the third power on the bottom. That's an example, right? So in this case, the horizontal asymptote would be y is equal to 0. So horizontal means left to right. If you want to draw a little thing for yourself, you can be like horizontal asymptote. As you guys remember, horizontal asymptote just means the part that your graph just never touches, right? Never touches. The second scenario is where m is greater than n. Then we will not, there is no horizontal asymptote. Okay. So the second scenario is where the variable on top is greater. So as an example, if you have x to the third over x squared, then there is no horizontal asymptote. Okay. That's the second scenario. The third and final scenario is where they are equal. So let's just say the exponents are equal. So let's just say we have, then it will be a over b. So as an example, if we have 5x to the fourth power over, let's just say 4x to the fourth, then this will be equal to, your horizontal asymptote would be y is equal to 5/4. So you would have a horizontal asymptote at 5/4. So the three different scenarios, I'm just going to say again, the first scenario is where the denominator or the exponent on the bottom, right, that exponent is bigger than the one on top. Whenever that is true, then you will have a horizontal asymptote at y equals 0. If the exponent on top is greater than the one on bottom, then there is no horizontal asymptote. If they are equal, then you look to the constants of both of those variables with the highest exponents, and then the top divided by the bottom is your horizontal asymptote. So if we look at our first example here, we can see that after it's simplified, it's 5 divided by 2x minus 7. So that means the top one has a variable of x to the 0 power. So the one on the bottom, or the denominator, is greater than the one on the bottom. So if we're looking at this, it would be scenario number 1. So for this, our h of a would be y is equal to 0. So in this case, we look at the variable on the bottom, it's x, and we look on top, there is no variable, so that means you would think the variable is x to the 0 power, right? X to the 0 power. Okay, so for the third thing we would do is your vertical asymptote. Your vertical asymptote is when the denominator, or when the bottom, is equal to 0. So when the number on the bottom is equal to 0, or the whole denominator, then we're going to divide by 0, which doesn't make any sense. So that's why it's a vertical asymptote. You can't divide by 0. So what we're going to do is we're going to set the bottom, or 2x minus 7, we're going to set that equal to 0. So set denominator equal to 0. So in this case, we're going to do 2x minus 7 equal to 0. And we add 7. We add 7 to both sides. We get 2x is equal to 7 divided by 2 divided by 2. X is equal to 7 over 2, or it would be 3.5. Okay, we got one last thing. Technically, we would have two more things. The last thing would be to graph it, but we're not going to do that today. That's a lot. So we're just going to introduce these 4 features of the graph. Okay, so the last thing here would be to draw the whole. So you're probably wondering, if we cancel out the x minus 2, so if I look at my original equation is 5x minus 10 divided by 2x squared plus 3x minus 14. That is still my original equation. I can simplify it like this. However, when I cancel something from the top and bottom, that part is still part of the graph. So what happens is that I have a whole at x minus 2 when that is equal to 0. Okay, so if I plug in 2 into my original equation, then I'm going to get 0 over 0, which is undefined, right? And that means that there's a missing point in my graph. When something's undefined, all it means is that when I plug in something for x, I don't actually get a y value. I get nothing. So if you put it in your calculator, you get an error message. So I know that there is a hole at x minus 2, or when x is equal to 2. So I know there's a hole if I'm able to cancel something out. Okay? I know there's a hole if I'm able to cancel something out. So in this case, since I cancel out x minus 2, then I know the x value for the hole is where the x minus 2 is equal to 0. Okay? Since I cancel out x minus 2, I know when x minus 2 is equal to 0, there is a hole. So when is x minus 2 equal to 0? When x is equal to 2. So what I'm going to do is I'm going to plug that back into my now simplified example. So now I plug in. And we will do some examples of this. This is something we're going to work on this whole week. So now we do f of 2 equals 2 times 2 minus 7, which is equal to 5 over 4 minus 7, which is equal to 5 divided by negative 3. Okay, so again, because we canceled out x minus 2 over x minus 2, there is a hole at x minus 2. Whenever x minus 2 is equal to 0, that's when the hole is. And so we get x is equal to 2. We plug in 2 into our simplified function, and then we get 5 over negative 5/3. So there is a hole at 2 comma negative 5/3. There is a hole at 2 comma negative 5/3.